it to start. I'll just revise whatever we did in the last. Yeah, so it is recording now. Okay, so for those who are watching recording, we forgot to switch on the recording, and so I'll just like briefly explain you what all we covered. So we did uh, the topics, messages, and nodes. So nodes are nothing but anything that has some computation running inside it. Yeah, the node is nothing. You can just read through this. You'll get everything mostly. Then about turtle sim, so you can use ROS run to initiate a turtle sim node. I'll just show it to you. Yeah. And apart from that, you can use this teleop key to control the turtle. Oh, I made a spelling mistake here again. I'll just correct it in the main video. Okay, before that, you need to start ROS core. So just keep in mind. I'll run turtle sim node over here. Yeah, so these two commands can be used. Just keep in mind this is a roster, and I'll just correct it when I'm doing this. Meanwhile, what topics are basically is topics can be used to convey information from one node to the another node. And yeah, okay, wait, it is taking time for this to run. Okay, we'll do one thing. I'll just record this part separately for the people who have missed, and we'll just continue with what we were doing. Right? So, never mind this. Yeah, just give me a second. Yeah. So, is my screen visible? Yeah. Okay, moving to. So I started ROSCore. Now we'll be making two files which Aayush told listener and talker.py. You can find the documentation on the ROS wiki thing. You'll get each and everything about the code that is there, and we'll be using the same code. Just I'll write it here step by step. Also, I'm installing VS Code right now, so it might take some time. So, okay, yeah, it is installed. So I'll open it. Okay, you can do this, or if you are like very cool, you can just start it in a terminal using code. Okay, so now we should have a place where we should store our code. So we'll go to our workspace. Okay, and oops. We'll do an ls, and as you might remember, we have our src package inside, src folder inside our workspace where we have our package. So instead of seeding like step by step, what you can do is you can use ROS CD and the package name directly. So if you do beginner tutorials here directly, so you'll directly go into the folder where there is beginner tutorials. So now I'll make a folder where we'll store all our scripts. So okay, there's someone at my door. Just a second. Okay, yeah. So moving on to the folder. Where is it? Yeah. So I'll make a folder called scripts. We'll quickly go into it. Okay. So if anyone of you has used VS Code before, so you can like open a folder here and you can work with all the things that are there in that folder. So I'll just skip all these things. Just I'll make my theme which I like. Yeah, that's it. And now you need to install some extensions here. So one is since you are working with Python, you can type, this is the extension window. Wait, is it like, yeah. So this is the extensions window. You can install Python from here. You just need to click install on Python and it will automatically install. For C++, there is one extension called ROS, I think. Yeah, you can install this too, but like we won't be working with C++ because of certain issues which Aayush will explain later. So will not be using C++. And if you want to work in C++, you'll also need C++ extension which you can install from here. So I just install everything now because anyways we'll be using this. Okay, leave C++. So yeah, you can open a folder from here, or what you can do is you can go into the terminal, you can go into which folder you want to open, and you can write code dot. So what dot is, it signifies that this folder, so current directory is dot, or you might remember there's a command called pwd. So what, it's not exactly the same. Dot is like just the current working directory. So it will open code, and in code it will open the current, like present working directory. So I'll just use this, and so I'll close the old window. You have to do yes, I trust the authors, and then you are in the folder called scripts. So here you can make a new file, and I'll name it talker.py, and it will show a small Python symbol over here. And yeah, so it will give colored syntax when you import anything here. So let's say you import math, so your import will be pink and your library will be green or something like that. It depends on the color theme. They're just saying for information. Okay, so moving on. So for those who are in 18.04, you need to like write a line called, like not called, you need to write a line which I'm writing here. Okay, so I'll just be writing the code and Ayush will be explaining it.
Yeah, so for those of you who are using 18.04, we'll have to write a line hash exclaim slash user slash bin slash env space python. So what this basically does is that it tells, so when obviously we're going to be executing the scripts from our terminal, right? So it will tell the terminal that this is a Python 3 script basically. Like it will change the environment, like it will change the environment path to Python 3, and it will be Python 3 for 20.04 users. So 18.04 users can just write env Python, but for 20.04 users you have to write Python 3. Yeah. The next thing is that we'll have to import ROS Pi. So yeah, and like Pranit explained before, we need to import from standard messages message import string. Yeah. After that, so you remember, like when we were creating our catkin package, like we specified some dependencies. Catkin create package, ROS-Pi, ROS-CPP, and then STD messages. So now, I mean ROS-Pi and ROS-CPP, you might have got a feel of why we were like giving those dependencies in the package. But now I think you must have also understood why we gave standard messages as one more argument. See, because we're going to use standard messages to use the string function basically. So yeah, that is there. Apart from that, the next thing is that if name equal to main. So basically what happens in C++ you have that function, right? Int main. That is a main program which will run, and you have separately defined functions on top of it, like, and if you want to use a function you have to call that function within the main. So for Python it is somewhat similar. It is basically the main part of the program which will be executed, and all the other dependencies in that will have to be specified inside the main function. So yeah, that is what is name equal to main. Apart from then, before that we have to create a publisher object. So we'll let pub is equal to rospy.publisher. So first we'll make a function for like a talker function.
Okay, yeah. So about this, so yeah, we'll make a function called talker, which we'll be using in the main function. So like as you might have learned this in C, like you make a function, let's say int add or something, and then you add arguments to this, and then you execute it in the main function. So this is like what exactly we'll be doing. Except here we'll do something which is called try and except. So what try and except does is it will try if the function is executing. So I'll write the code for the function later, and if it's not executing, then we'll add an exception condition. So it is written as except, and then I'll just write this line, and I'll explain it at the end of this code what this line means. So it is Ros Interrupt Exception. So okay, I'll just tell it now. So you might know that whenever we need to stop any running script or any running code, we just press Control C on the keyboard, so it stops. So that is what this ROS interrupt exception means. So yeah, you can read the description also by hovering your mouse on it. So it's written that exception for operations that interrupt due to shutdown. So if you just press Control C, then it will switch off on its own. So this is the basic structure of our main program. So in if you see in C or C++, this is nothing but like in main int main void, and then try this, or if it doesn't work, then you like this will happen. That's it. So nothing very different is happening. Just the syntax is different, because that's why it's looking a bit tough. Okay, now here I'll create an object called pub. This is a publisher wala pub, not any other pub. And so okay, in the beginning you might feel that this code is a bit like going above our heads or something, but yeah, like when you read through it you'll understand. Okay, so rospy.publisher is a way of initiating a publishing object. So pub will be an object that is used to publish something, and how will we make it publish? Using this publisher function, which is inbuilt in ROSPy. So if you hover over it, now you can see what all arguments you can put in. So you can put in name, data class, subscriber, listener, and I don't think any other things are relevant to us at this point of time. So now I'll write three things inside this the function. I'll write name. So you have to recreate a node which is called something. So that will be your name. So the message will publish from that node. Okay. Then data class is nothing but the message type. So we are using a string message because that is what we need. In the case of ROS, like the turtle thing, you saw there was like linear XYZ and angular XYZ, and that was called twist. So if you want to use that, you can just, in that case, you can just like do from, you might remember it was geometry messages, and from that you will import twist. So that is how that works. But right now you don't need this, so I'll just comment it out. Yeah. So here I'll write the name, which is, let's name it chatter. So our node will be called chatter. The data type or the message type that will, oh, wait, what happened? Yeah. The data type or the message type we'll be using is string. And then we'll write a queue size, which is 10. I'll come to the queue size part later after this code. So yeah. Now, so we have made a publishing object, and it will publish from topic this, and it will use the message this, and Q says we'll explain it a little later. Now I need to initiate this node, uh, or I think we should explain Q size now itself. Yeah, Ayush.
Yeah, so queue size is basically the size of the message which will be going out. So like we were discussing about how much memory it occupies, right? So maximum queue size which we will send will be 10 bytes of memory. So for example, if you are sending a string which is occupying more than 10 bytes, so okay, I think you all might know a character occupies 1 byte, right? So yeah, so like if you're sending a message, say something like hello or something, so that the size of hello will be like each, if you take 1 byte each, it will determine the size, say 5 bytes or something. But if it's crossing that queue size, then it will only send the message till that queue size is reached, and after that it will go to the next message. Yeah, that is basically it.
Yeah, like this was just a like a basic explanation. If you want to know a detailed explanation of what each of these means, you can in VS Code you can just hover over anything and it will tell you about what that is. So if you go on this function and you scroll, all the parameters and what they do is listed here. So you can just read through this if you don't understand anything. So as we used name, so resource name of topic. So this is basically the name of topic that will, so the name of okay, topic that we'll be using. Name is just a string, and what else are we using? We are using the data class, right? So yeah, data class is a message for serialization, message class for serialization. So as we told before, message is nothing but a class, and the name of, like, the type of that message is what you're writing here. So okay, I hope everyone got this line right. Please like interrupt us, because this is very important. If you miss out on this, then later you might have problems. So anyone?
Could you explain what the node is again?
Yes. Okay. So as I said, this is the publishing object. Okay. So okay, about the node, I'll write next line, and then we'll explain what the node is and what the topic is here. So apart from that, anything else regarding this publisher object? That's it. Nothing else. Okay. So moving on, now we'll create a node. So how to create a node? So of course in the ROS Pi there is an inbuilt function called init node. So you use that init node, and here you can see the arguments. Like if you hover on this, you can see name, and then you have anonymity, then you have disable ROS time, all this stuff. You can read about everything here. Right now, what is relevant to us is the name and the anonymous nature of it. Okay, so I'll write, let's call it, okay, so since this function is called talker, so I'll just call the node also talker, and I'll set its anonymous to, let's set it to for, okay, let's set it to true for now. So okay, so now as you asked, so our node will be talker, and the topic which we'll be using is chatter. So if I open Jamboard and like try to depict what we are doing. Yeah. So previously we saw an RQT graph which was like, here we had turtle teleop, and here we had turtle sim node, and this was the CMD well thing. So we are doing something similar here. This will be our talker, and this will make afterwards, and this thing will be chatter. So this is what we are trying to do now. So how to make this is ROS Pi dot init node. I can't write it here, but yeah, init node, and this was made by ROS Pi dot publisher.
Yeah, so about this anonymous is equal to true thing. Basically, when you're writing like a publisher node and you want more than one listener to listen to it, So what will happen that two if two nodes are named with the same, like if they are given the same name, what ROS does is that it kicks off the, if you have one listener named listen, one listener node named listen, and the other one is also called listen, then the first one, once it connects, and if the second one also tries subscribing to the same publisher, then the first one gets kicked off. So what this talker.py file will do, it will do a very amazing thing. It will append a number to the end of the node to which like it's listening. So for example, if you have another listener.py file, so if you put anonymous is equal to true, it will append say a number, say 1, so it will become listener 1. Then again, supposing another node subscribes to that, it will become listener 2 and listener 3 and so on, so that you will have unique nodes which are listening to the same publisher. And it's not only numbers, it could be anything. It could be, it's basically a unique character which is appended at the end of the name. So yeah.
Yeah. So yeah, Ayush explained the anonymity of it. So okay, whoever asked the doubt, are you like clear about what we are doing, or do I need to explain something again? Hello. Oh, there is some chat maybe. Okay, fine. So yeah, moving on. Okay, so now what we have done is we have our publishing object and we have our node which is initiated. Now after that, what we'll do is we'll define a rate. So rate is nothing but like what rate will be publishing to it. So it can be like as long as one message per second, or like 10 message per second. So nothing in hertz. Okay, so I'll just write it down here, like just commenting. We made a publisher object and a node. So node is named talker and the publisher object is called a pub. Okay, so this is the first part of the code. Also in Python, take care of the indentation. This should like be exactly 4 tab spaces here. If you can see clearly, there are like 4 dots. So these are all the empty spaces here. So I think it's 4 in VS Code. I don't know about other IDs. So moving on, we'll define a rate at which we'll be publishing to it. So for a rate, so rate is what we are, rate is just a variable, and so we'll set it by rospy.rate, and let's make it let's say 50. Okay, 50 will be too much. Let's make it 10 hertz for now. Okay, so yeah, going to the rate part. So it has just one param and reset. We won't be resetting it, so I'll just not write this. By default, it is set to false, and HZ is just the rate to determine sleeping. About sleeping, we'll write the line for that also, and so we'll write the line for that and we'll explain it to you later. So this is the rate at which we will be publishing. So we will publish at the rate of 10 hertz. Yeah. So now we have made our object, we have made our node, and we have decided the rate also. Now we'll be using while loop for publishing the message. Now it's like to like just recall what a while loop is. Like in C, you used to write like while condition, and then here you had like what you want to do, like anything, your statements would be here. So in Python, you don't need brackets here. You can just write your condition here, like condition whatever, and then you can do a similar colon and you can enter. So you'll enter a while loop. So our condition here is like as long as ROS is running, we will publish to it at the rate of 10 hertz. So for that there is a thing called is shutdown. So while ROSPy is shut down, so it's saying that if ROSPy is like running, so if it will execute, but if it gets shut down, so it will exit this while loop. So that is what this command means. If you go there, true if the shutdown flag has been set. Okay, so that is how it works. Now what we'll be writing, so here we need to publish our object that we made. So let's decide what we want to publish. We'll publish a string saying that, let's say hello world or something. Okay, so I'll make a string, let's say hello string. And okay, so this will be hello world. And okay, so we need to differentiate, like all the hello worlds is being published. So I'll add one more thing. I'll add a string to it, another string, and that string will be the time that is there according to ROS. So you can write ROS by dot get time. Is it get time? Yeah, it is get underscore. It should be here. Get time. Yeah. So this is how you get time in like ROS. Or what you can do is you can import time from here, and you can use that as well. So yeah, it doesn't really matter. Okay. So this is how you'll get a time. So if like each time it is published, you'll have a different value here. So it'll be like hello world and then some time. So next thing we'll do is we'll print a string whenever we publish. So I'll just use print, and then I do hello string. Yeah, here. And then what you want to do is you need to publish this thing. Okay, so now I'll do pub.publish and hello string, because that is what it will publish. So what is happening is okay, this thing is right now this thing is not relevant to us. So this thing works if I run this thing right now. Okay, so this will just keep printing hello string. This will not publish anything. But since after this we'll make a subscriber also, so we need to write this so that this in this information gets published onto this topic, and it's received by the another node that we'll just make, which will be called listener.py. Okay, I'll just make this later. Now after that you have to sleep this. So what sleep is that Ayush, would you like to explain?
Yeah, so basically, when you initiate ROS.sleep, it is kind of similar to time.sleep. Basically, it will stop the while loop for enough amount of time in order to receive a message from the listener.py file. So, we haven't created the listener.py file yet, but you'll see that we are also including one string in the listener.py file to receive output from there, saying that okay, yes, I received your message. So ROS.sleep will tell the code to wait for a certain amount of time to receive the message from that listener.py. It is kind of similar to time.sleep, except in time.sleep you need to specify the like amount of time for which you need to wait. So I mean it's basic calculation. So if you say ROS.rate is 10 hertz, so that means you're sending it at a time period of 1 by 10 seconds. So you'll have to do time.sleep 0.1, or if it's in milliseconds, I think time.sleep 100. And okay, so for those who might have used Arduino before, it is sort of similar to delay. Um, but yeah, for ROSPEC. Yeah.
Oh, okay, yeah. So yeah, this basically kind of pauses the while loop so that it can receive information. But yeah, so I think we went through this like very quickly. So yeah, okay. Now we are done with the while loop code. So this is it. Nothing else needs to be added here. So I'll just go through each and everything once again, so there is a clear idea of what this is. Just like give me 10 seconds. Yeah. Okay. So first we made the main function, which is we'll try executing this function, and if it doesn't work and there is an exception given, then it will stop, otherwise it will throw an error. So that is what we did here. You can use this exact same thing, just change the name of the function whenever you run this. You don't need to go deep in what this try, except, and all the things are. Also we imported ROS Pt. Okay, this line comes like automatically if we do something, so no need to worry about this line. So we imported ROS Pt first. Okay, first we imported ROS Pt, then you write this, and then we imported a message which we'll be using here. Then we are making a function. We made a publishing object. Okay, and this will use the topic called chatter to exchange messages, not to exchange. Basically, it will use to publish message because this is a publisher. If it was a subscriber, then it will use this topic to subscribe. It will use a message called string, and like the queue size will be 10 for it. And if you have anything, like if you don't know what all arguments are, you can just hover your mouse over this and you will see each and every argument here. So when you try this on your own, which is highly recommended, you'll get to know this. Okay, then we initiated our node. So our node will be called talker. Anonymous, it will be true, like anonymity is what Aayush explained. And so what we did is we created a node called talker, and we made a like publishing object which will use the topic chatter. So it will throw this object in here, and it with this topic it will go somewhere. Somewhere we have to create, which we will do it in a while. And okay, where is it? Yeah. Now we set the rate at which we'll be publishing, which is 10 hertz. If you want, you can put it like 100 or whatever, but if you make it like too much, your PC will hang or something. So it's like 10 is, I think, the ideal rate at which anything happens which does not need immediate computation. So yeah, now we now we need to publish this object. So what I'll do is, okay, I've never tried this before. Okay, first we'll run this normally, then we'll make a few changes to this code, so you'll basically know what is happening. So this hello string hello world, this is what we'll be publishing to our subscriber. So let's say we are the editor. So for us, the newspaper is this hello world slashes, and slashes is nothing but the time will be printed in place of slashes, and the newspaper boy is the chatter, and it will be going to some person, we don't know him right now, and the contents of newspaper is this hello str, which is basically this. Now to publish, the format is like you need to have your object here, object dot publish. This is how you publish, and here you need to write what variable you are publishing. So that is how it's written. Also, I think many of you or most of you don't know about classes. Okay, you know about structs, right? So in struct, what used to happen is you made a struct, let's say node or something. Okay, not node. You made some struct ABC, and then you used to write here A, then B, something. And then when you access it later in your main function, inside main, what you do is like you do struct ABC, let's say some X, okay, and then if you want to access, you do use x dot a equal to and then x dot b equals to. So this is how you access it, right? So this is a similar, okay, in struct you can only store data types if you know, but in classes you can also store function. So how classes are made is instead of this you can put class here, and that is how a class will be made, and you can use data types as well as you can like put some like small functions in it. So here if you see ROS Pt, so this is not exactly what is happening, but ROS Pt is being used as a class here, and all these publisher, init node, rate is shut down. All these are functions inside that class. So if you want to know about it more, you can like go to right click it and go to, I think, declaration or something. Okay, not declaration. You can, I think, go to. You'll find something definition. Huh? Yeah, so you'll find all the documentation of it here. So you can. It's very difficult to understand this if you're very new to this, but yeah, you can like go here and you'll find all these things there. So okay, moving on. So now we'll publish this, and then sleep is, we'll wait for it if something is coming, or else it'll again enter the while loop, and this will only stop when this shutdown trigger or shutdown flag is set. So if we do control C, then only it will stop. Okay, I think it's a bit too much of info, but you'll understand what I'm doing right now. So if we do, okay, I'll save this first. And okay, if we do an ls here, you can see we have listener.py and talker.py. So you need to make this executable first. So you want to say plus x, and like we'll make both of it, so you can just write star, and you can see you have both the files made executable. Now okay, since you added a new file to your package, you need to build it. So I just go to the workspace and I'll build it. Catkin underscore, okay, not underscore, catkin build. Oops. Build, yeah. Yeah. So one package succeeded. So this shows that there is some change in the beginner tutorials folder, and now you can run it. So I already have ROSCur running, and if you remember the ROS run part, the package name is beginner tutorials, and this thing is called talker.py. Okay, there's some importing issue, I think. Okay, we use the class, right? So it automatically adds this. We don't need this. So I'll just save it again and I'll run it here. Yeah, so I'll just catkin build again. Yep, and hopefully it should run now. I'll just check the code once. Yeah, I think now it should be good for running. We'll see if any error comes. Cannot. Okay, sorry for that. Okay, so I found the error. So this file is called standard messages.message. Sorry for the confusion created here. So this string is stored in this file. So that is all it means, nothing else. So there was an error while importing. Keep this in mind. And now I think it should run properly. Oh, okay, we need to save it. Sorry. Yeah. Okay. Now it's not showing any output, but okay. So instead of print, what we can do is you can use rospy.loginfo. And you can use hello underscore hello like this. So this is nothing but it is a modified version of print. So it will show you like it will show you the log info as well. So okay, just excuse me a minute.
Sorry guys, like forgive us again. Some connection issues. Yeah, we'll be back like once sorted.
Yes, am I audible now? Hopefully.
Yeah, you're audible.
Okay, fine. I'll present. So I had to restart just a minute. Yeah. So we had raw score. Oops. And okay, so we are in the beginners tutorial thing. So we'll raw straight into beginner tutorial directly. And we had a folder called scripts in it. And we'll open this in VS Code. So that's what we did till now. And yeah, so this is the code that we had. So I'll try running this here. So we'll do ROS run. Then we'll do the package name. So the format for this is ROS run, package name, and the file name. And here I'll do talker.py. So this is it's running. So now you guys might be thinking that we just planned. Okay, I'll just end this here. I'll press Ctrl C. So we guys just planned to write this, but what is this? So this is what like the change I made here. So if you just write instead of this, you write print hello str. So and I'll just comment this out. So here what is happening? It will just print. Okay. So I'll just use a new terminal for this. Yeah, same thing. ROS run. Okay, I didn't save. I think. Yeah. Okay, so this small dot, if you can see it here, then you need to save it first. Then only it will run. Yeah. So here now, as you can see, it is not showing any info. It is just straight away printing stuff. So now this is not being published anywhere, right? So we need to make something where this is being published. So we'll just use log info instead of print right now because it is more informative, I would say. And yeah, this is the time according to ROS. Also, one important thing, if you notice, so yeah, just a minute. Yeah, so here you can see this is like this is the time and this is the time. So the difference between these two times is 0.1, right? And 0.1 second is basically what 10 hertz is. So that is where your this thing comes into play. So yeah. Okay, so anyone has anything to ask about from like regarding this? We had some issues in between, but yeah, now it's like compiled together. So I'll just go through this once more, and then we'll move to listener. So we imported this. Okay, keep in mind this is the file name, and this is what we are importing. So please don't make this mistake as I did. Then we made our publishing object. Then we made our node. Then we decided the rate. Then we made a while loop, like ROS by while not ROS by shutdown. It should work. So if it's shut down, it will stop. And how is it shutting down? When we press Control C, or else the ROS score is like press the ROS score like ends or something. So that is how it shuts down. And then we made a string, like what we want to publish. Then we can use ROS by .loginfo, or you can use normal print. And this is when you will publish it to this. Right now we are not publishing, so there is no use of putting this, but since we'll be using it, so I'm just letting it stay there. And this is sleep, so it will wait for anything. And this is the main function. So it is a bit confusing in the start, and it is a bit tough to understand, but I hope it is like clear to everyone before we proceed. So I think we'll yeah, so anyone has anything to ask, you can just like mute or unmute or like type in chat or something. So I'm assuming everyone is thorough with it. Also, like I don't have the PDF right now. I have it in my different like I have it in my Windows, so I'll just share it afterwards. Moving on to listener. So for listener, so okay, by now, okay, the Jamboard is also closed. Yeah, good. Also, yeah, one more thing. This print was just like a test of what is happening really, because in the working there won't be any printing or something. So this was just for us to confirm that this while loop is working. If you remove this while execution of your main program, so there is not an issue. So yeah, just saying. Okay, so in listening, you need to add the first same line. And okay, even ROS Pi you'd have to import. So that is done. Now, okay, even we'll need a string as well. So I'll just do that also. So we have made a string. Also, our main function will be same as I said. Every single time you do anything, the main function will be same. Just instead of talker, I'll put listener, and we'll make a listener function here. Yeah. Okay, like one thing I wanted to ask, is this like too much for today, or you guys want to okay, did not understand now. Okay, y minus 1. Yeah, right. So, one second. Yeah. So in a 64-bit, like whatever, you have 64 like the bit slots. I don't know the exact name for this, but yeah, you can store like 64 bits, like 110 whatever. So your maximum number which will be stored here is 11111111. So it will be 2 power 0 plus 2 power 1 plus 2 power 2 until 2 power like 63 into your like whatever the bit is. So let's say it is, let's say a number is 5. So the binary for 5 will be, it will be 4, it is 4 plus 1, so it will be 101, and all the rest here will be 0. So it will be 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1. So it starts from here 0, 1, 2, 3, and these are your two powers. So the maximum, like for 2 power 64, it will have to be the 64th. So it starts from 0 and it will end at 63. There won't be a slot for 64. So that is why the number will be like 63 times 1 will be your maximum number that can be stored, which is nothing but 2 power 63 minus 1. So if you do like, if you add 1 to it, so it will become like a 65 bit, you can say. So that is the reason why we use this. Anything else? Yeah. Okay, yeah. So I was asking, like, shall we end it here or shall we move on to the listener part? Because I think people will get time to like understand this. So it is your call. You can type in the chat. Shall we continue or not? Yeah. We can like take. We can extend. The listener part will, I think, take about 25 minutes maybe. It won't take long because you're already familiar with what all these things are. So that is why. So do you want me to start with it or like what? Please respond someone. Windows also. Okay. Fine then. Okay, so what listener will do is like this is publishing, right? So this part is publishing to from a node called talker using a topic called chatter. So what we'll do is we will now subscribe to this topic. So what we are doing is, did I make it? No. So until now we have made this talker and we have also initiate this chatter, and here we have nothing. Okay, so this thing is listener. So at the end, what should happen is now this is like putting. If we go back to our code, so this is what is being sent as a. This is what is being published. Okay, so now the chatter will contain this information, and the subscriber, that is the listener, it will receive this information. So what we can expect is when we do a ROS topic echo for chatter, we should be able to see what all lines are there. Okay, so wait, is this still running? Okay. So I'll just run this again, and in a separate terminal, I'll do a ROS topic echo. And then I'll put, okay, before that I'll just see if the chatter is working or not. Topic list, and you can see there's, okay, I'll just, yeah. So you can see there's a topic called chatter that is working. And also for reference, I'll open RQT also. So right now we don't expect to see anything apart from talker. Also, this weird number is there because of the anonymous nature, which was set true. So if I make one more similar talker node, so it will be /talker underscore some different random number will be there. So these one don't overlap basically. And since we are not public, there is no destination for this. The topic is not being shown, but it is being used. So if I do ROS topic echo, where is that? Okay, if I do ROS topic echo here and /chatter, oh, yeah. So this is what it's sending right now, and this is the same thing which is going on here. Also, this is not showing log info because we are not publishing log info. It is just a way of printing. So the real data is this part after the colon here. So this is the data, and this is what this is showing. So good to go, I think. Yeah. So now we'll make a listener. Okay. Now the steps are almost similar. There's just one addition to it. Okay. So in the listener also, we'll need to mention from what we are listening and the topic that we are using. So we'll initiate the node. And can anybody tell what the node was called? Or what the node should be called? We can give it any name. So I'll just give it listener for like better understanding purposes. And if you go on init node, the anonymity was mentioned. So we'll make this anonymous true as well, because we don't want overlapping. So it should show listener underscore some random number. Okay, the next thing is we need to make a subscribe. Okay, we need to make a subscriber object also. So I'll just instead of using object, I'll just directly like write ROS.subscriber, and it is similar to ROS.publisher, but you don't need to make an object over here because you won't be using this. It's just there for getting the topic. So you can see it has the same arguments, name, data, class. And okay, this has an additional thing called callback. So I'll explain it later. Now, okay, so the topic that we are using is this chatter. So I'll write the chatter here, and the data class is string. And okay, so one more additional thing we need to add is callback. So I'll just write it here, and yeah. So what a callback basically is that I'll make a function here first. Okay, def callback, and what this does is like I'll write. So callback is like you're calling. Let's say you're the newspaper. Okay, you're the person who is taking the newspaper. Okay, so you're taking the newspaper from the newspaper guy to your dad who will be reading it. So you are the callback. So you'll be taking the newspaper from the the topic, and you'll be giving it to your dad, who is the node. So that is the job that this callback is doing basically. So we'll write a string like I heard this from the topic. So you can do print also, but I'll do log info. And okay, so we'll also get a caller ID, which is nothing but a unique ID to each message that will get published. So you can remove this if you want, which is not a very big issue. I'll do it that way also. I'll just write the thing. Plus let's make a string like I heard this from the topic that is there. So I heard dash, and here I'll write data, and here also I need to provide an argument which is data. Okay, so now what this data is, uh, I think it should be better if we like go through this later on. What is happening is if there is any data in the chatter topic, so it will just take that data and first it will print this and it will give this to the subscriber. So this is what this code means. Okay, and after we are done, so we'll have to do a ROS.spin. Okay, now what spin means I'll just tell you in a second. And after like I write the code, and also I'll have to do ROS.sleep, or I think sleep won't be needed. Yeah, sleep won't be needed here. Okay, so what the spin is, it just prevents the thing from exiting until the node doesn't exist. So what we did here was we used a while loop for it, and we used to sleep every time, right? So while while it's not shutting down, you need to publish everything. And here, so we can't subscribe to anything if there is no data, right? So we'll just write it as if there is like a node. So you just keep subscribing. If there is no node, then you stop. So that is what spin means. Even like I'm not sure why they have given this terminology for this thing, but yeah, this is what it is. Even if you read this, blocks until ROS node is shut down. So when a node is shutting down, that's the time when this will stop. So this is basically what a listener is. And yeah, also like the listener will just run when any node is there, so you don't need all this. You can just write a listener here. Okay, not the call. Yeah, so you can do that of course, but this is just a simplified way of doing it. I think yeah, we are good to go. So I'll just save this, and now we need to do a catkin build again. Yep. Yeah, so catkin build is completed. We have our ROS core running. So also like one more thing, when you run the listener code, okay, oh wait, where is the code? Yeah, when you run the listener code, so you have to like have the chatter thing running, and for the chatter thing running, you'll have to like start the talker.py also, right? So we'll do one thing, we'll start the talker.py here. So this is now like publishing hello world and then the time, and here we'll first clear this terminal, and hopefully if there are no errors then it should work. If there is any error then we'll have to debug the code. So listener, okay, first the package name, beginner tutorials, and then listener dot py. Now yep, so this is what it's hearing. So if we go back here, is this thing confusing you guys? Okay, let's just use print instead of all this. Just a sec. Yeah, so wherever you'll find log info, I'll just use print instead of that, so that there is no confusion. And here, yeah, here also I'll just use print. Okay, yeah, this get caller ID is nothing but it will be the name of the node that is initiated here. You must have seen it here. So this will be the name of node that will be shown in the RQT graph as well when I start it. Okay, so I'll run this again. Yeah. So now this is what is being published, and here when I start this is what is being heard. Okay. So this is like some weird syntax because this doesn't work with print. So I'll just use caller ID instead. I'll just use log info instead. Yes. This node heard this thing. So coming back to the newspaper analogy, which I think will be much easier to explain. This is the editor. This is your dad, or like whoever, your elders, whoever are reading the newspaper. And this small kid is you. And this is the newspaper man. So this thing, he's writing it on a paper that hello world plus time. Okay, so this is being written on this paper. Okay, and this is our object. Now it is giving to the newspaper man who is chatter. Now he's delivering this to you. He wants it to give to him directly, but there should be a way of like like dad should have a way of getting the newspaper because he won't stand up from the sofa or something, or like I don't know how to put this up, but he gives the newspaper to you and he calls you to bring the newspaper. So you get this newspaper and you give it to your dad who is the listener, and you are the callback. So listener calls the callback to send information to him. He is the chatter and he is the talker. I hope this makes it clear what we are doing. Also, I can do an RQT graph now. ROS run RQT graph. Yes. So it is going from talker to listener with the help of chatter. Okay. What if we set anonymous here false in both the files? Now if we run this again, and if we run this again, and if we run this again, so yeah, the weird numbers in front of these things are gone. So this is what we actually made. Is it clear to everyone? Basically. Yeah, so this is it, the funda of like how a subscriber and publisher work. And let me also tell you a good news that you won't need to do all these things, because like yeah, you will need to, but it won't be this complicated. It'll just be a simple code which we'll be using in our drones. So even I'll tell you that also, drone.py, let's say. So the structure will be like same as this, but we won't have like, first thing, we won't have a subscriber because we don't need one, and even if we have one, it will be already made. So you don't need a publishing object or anything. In the while loop, you'll pass like what the velocity of the drone should be, or what the position of the drone should be. That, so that is how we'll make a drone code. So that we'll be doing in our next session, which is I think on a Monday. So yeah, your weekend task will be just like replicate this exercise and make sure everything is running. and you can try experimenting, changing the, let's say, queue size, or let's say the rate. So you can try doing that by yourself, and I'll let you know about the submissions on WhatsApp. Also, like if these things are not clear to you, please tell me, so we'll cover it up in the next session again. Yeah, now you guys can leave. Also, like, yeah, thank you for attending.
Thank you, bro.